Guys, Mr. Bowman here. Today's learning objective is in pink and we are learning to add, subtract, multiply and divide algebraic expressions. What I've done is I've split the screen up into three parts: adding and subtracting, multiplying and dividing. So we're going to start off with the adding and subtracting section. And just a reminder, for us to add expressions or for us to add letters, we have to have the same letters, and those letters have to have the same powers. So same powers. If that exists, we can add them together. If that doesn't exist, they are different things and we've got to keep them separate. So let's have a look at question number 1. We can see initially I'm only going to focus on the letters. I don't care about the numbers. I can see I've got x and x. We have the same letters and they both have the same powers, and in this case neither of them have a power. That means we can add them together. So let's consider these x's to be apples. So we've got 6 apples over here, another 4 apples over here. How many apples do you have in total? 10 apples. So we've got 10x, and it's really important when you're adding and subtracting, the letters don't change. It's the number in front that does change. Let's look at question 2, and again we're starting just looking at the letters. We've got an A and a B, so straight away I can see I've got some different letters. And then I've got another A and another B. So I can only group them together or put them together if the letters are the same with the same power. And I can see these A's, I've got 6 apples, say, and 3 apples. That's going to become 9 apples. 9a, and again the letters not changing. It's not a squared, just a. And then let's deal with the b's. 10b minus 8b. So we've got 10 apples, 10 bananas. We've lost 8 bananas. We've got 2 bananas left, so positive 2 bananas. We're now on to question 3. We can see we've got a squared b, ab, ab, a squared b. Why it looks like all the letters are the same because there's only a and b's. Some of them have different powers. So if you have a look, we've got a squared here and a squared here without any squares on the a's for the 6 and the 7. So the 2 with the squares in, they have the same letters and the same powers. So we can put those together, and we can put the ABs together as well, but we can't put them all together. So let's say we got four of these and we've lost 2 of these. We're left with 2. So that's going to be 2a squared b, and 6 or 7 of these, we've lost 6. We're now left with 1. So we're going to go plus 1ab. You can even write just plus ab. Both versions of that answer would be correct. So that's the recap of addition and subtraction. Hopefully that makes sense. Same letters, same powers. We're now moving on to multiplying, and normally with regular numbers, multiplying is often the annoying one, but with algebra, I think multiplying is the easiest one. So when you're multiplying, always start off with the numbers in front first. And then once you've done that, you can deal with the letters, and you deal with them individually. So you just deal with the x's, then you deal with the y's, then you deal with the a's, whatever letters might be. So question number 4, numbers first. 10 times 4 is 40, and then we deal with the letters. I've only got an x, so that's not going to change, just an x over there by itself. So we've got 40x. Question number 5, deal with the numbers out front first. 5 times 3, that's 15. Then we deal with the letters. We've got an A and a B, so we're going to write A and a B. The last one, letters or numbers first. 2 times 6 is 12. We then deal with the letters. I deal with them alphabetically, so we can see we've got a single X over here. And this one's a bit different because you can see we've got a Y here and a Y here. Don't forget this Y squared. That is actually Y times Y. So I've actually got 1, 2, 3 Y's. So there's going to become y cubed. So hopefully that's a good recap of multiplication. Follow that two-step approach, deal with the numbers up front, then you can start looking at each of the letters individually. And our final one, dividing. Dividing's a bit annoying, but I like to change my division questions so it looks a bit like a fraction. Hopefully you can see what I've done here. I've got 10x, I'll put that on the top. Divide by 5, put that down the bottom. Once we've got this, the same process to multiplication actually works for division as well. I'm going to start off with, well, what's 10 divided by 5? That's going to become 2. And then we've got the x over here. So in theory, we've got the denominator, but there's nothing there left because that 5 has gone away because we've used it to divide by the 10. So we can just leave that blank. But sometimes there is stuff on that bottom, and that last question will be an example of that. So we've got our next question. We've got 30b divided by 6b. Same process. Let's look at the numbers first. We've got 30 divided by 6. Well, that's going to be 5. And we can see we've got b divided by b. And when there's a b on the top and the bottom, they cancel each other out, leaving us with no b. We can just ignore that. They've cancelled each other out. The answer is just 5. No b's. And the final question, question number 9, we've got 15a divided by 5ab. Same thing. Let's deal with the numbers first. 15 divided by 5, that's going to be a 3. The a, you can see there's an a on the top and bottom. I'll cancel them out. And so the 15 and the 5 are gone. And that just leaves a b down the bottom. So it's important, don't put the b by the 3 this time. We've got to put it down the bottom because we're not doing anything on that b. We can't just move it up. We've got to keep it down the bottom there. Hopefully you found this quick recap video on adding, subtracting, multiplying, and dividing algebraic expressions useful. Let's get into heaps of practice.